Hello everybody, welcome back. I'm going to shift gears in this video. This is something I haven't done before, but the response to the ring modulator project was so fantastic last time. I appreciate everybody chiming in, especially I'd like to thank Sebastian Asevedo himself for chiming in with a couple of suggestions on how I could improve the output of the project. But I'd also like to thank everybody else who had some suggestions or just some questions about what happens if you do something. So first up, let's take a look at Sebastian Asevedo's suggestion. He says placing a log amp stage before both inputs made of the same resistors and diodes will yield a much wider dynamic range version of the circuit, and it won't have the scaling and crossover and dynamic range problems that we were experiencing in that first one. Right, so this is a log amplifier, which is going to take our input signal for the guitar and for the carrier signal, and it's going to route it through what might look like a clipping amplifier in something like a tube screamer. But this is, again, these diodes are not for clipping the signal. What they are is the diodes are voltage-controlled resistors in this case. So I have my signal coming in, and depending on the amount of voltage that's coming in on the positive or the negative swing of the signal, these resistances, they're going to start off large, and the more voltage that's coming through, this resistance is going to go down. So it's going to have the effect of when the signal is low, it's going to amplify it a lot. When the signal is pretty high, these resistances go down, and it's going to amplify it less. So it's going to have the effect of kind of compressing the signal, and this is the increase in the dynamic range that Sebastian was talking about. So this amplifier is going to be used on the front end for both the guitar signal and for the carrier signal, and then it's going to go off and form the A and B inputs of the original circuit. Clock signal's coming in, hops over to here. I've got it going in through a 10K resistor into the negative. Positive is going to ground. From the negative, I have feedback diodes pointing each direction. So that's my log amplifier. The output of that is going to my A and B sides. Input signal comes in through 10K, two diametrically opposed diodes, and then he goes off to my A supply. When the guitar signal is coming through more clean, that is some nasty noise though. So it's a little bit too hot going in. Might could change those resistors, drop it down, or put a volume knob in here. I don't know. We'll try that next. Okay, so absolutely adding the log amplifier in for both channels, for both the external clock input and for the guitar input, that boosting it definitely makes a difference. And that's just crystal clear. It even has some sustain. For the next couple of questions, somebody asked, well, what happens if the input signals are reversed? Does it sound the same? And theoretically, I think, yeah, it should, because the original equation that we were solving, a plus b squared minus a minus b squared equals 4ab, the fact that the inputs are being swapped really shouldn't matter in the end result. But just to make sure, let's give that a listen. First example, as is. Here's the clean tone. Another carrier input question that I had was, what does it sound like with different carrier waves? Everything that I've done up to this point has been with a sine wave, and it sounds nice and bell-chimey like. But what about a triangle, and what about a square wave? What about a sawtooth? Let's give those a listen. What if that second input, the carrier signal, instead of being this frequency, what happens if it's just DC? Does the whole ring modulator turn into a voltage-controlled amplifier? Okay, so now I've got potentiometer here, 10K, which is going to go from my positive rail and gradually scrub down to ground. So he's going over to the carrier. All right, so right now the voltage is at ground. That is so absolutely sensitive, it's ridiculous. Does it become a voltage-controlled amplifier? Kind of. It becomes a distortion pedal is what it becomes. I go from almost nothing That is ridiculous. That is way too hard to control. So I wouldn't recommend it as a voltage controlled amplifier, but there's some pretty nasty distortion. That might be kind of a cool thing to do. All right, on to the next thing. The last comment I have is from Emily Bakes, or Emily Bacchus, and she says, to make a ring mod sound pretty, try a much lower carrier frequency, going from near zero and gradually building up the carrier frequency, and just until you get that frequency separation. We're going to give it a try. It may not work. We want to try extremely low frequencies. All right, this is not going to be continuously variable, but I have it on as low as it can go, 1 hertz. And this is just a sine wave. It's pretty weird. Now for this last example, several people mentioned that, hey, a ring modulator was used for a certain voice effect in Doctor Who, namely for the Daleks. And just for fun, I wanted to throw this in here for you guys. This is a microphone I've got that's made out of an old telephone. Well, that was fun. Anyway, thanks to everybody for asking questions and wondering what else this thing can do. Especially thanks go out to Sebastian for suggesting to put the log amplifier in the front of the circuit to boost the headroom and to level out the dynamics and such. Greatly appreciate that. So what did we learn? This is an extremely versatile circuit. Unfortunately, I do hear some distortion, even when the tone should come out pretty clean. I think that's most obvious when I ran the DC signal in for the carrier. It worked as a voltage-controlled amplifier, but it also really pushed it into overdrive and into distortion. It was probably pushing up close to the positive and negative rails, and it just wasn't able to do anymore. Or perhaps we're starting to see some distortion because we are pushing this through a diode. And even though in the description I keep saying that the diodes aren't there to perform clipping, I think some of that is just going to happen by the nature of the circuit and the fact that I'm pushing the gain level so high. Who knows? I also definitely hear that this thing is capable of producing all kinds of extra harmonic overtones. They're not always pleasant because when we're blending the two different carrier and modulator signals, you get that funny frequency spread, and it's meant to sound weird. It's meant to sound ugly. And I understand it's not for everybody, but moving forward, I'm going to be pushing the guitar signal into both the carrier and the modulator. And something interesting happens when you use a modulator and you use a signal to modulate itself. You should get an octave up effect. And I didn't try that here. I've checked it out on the scope off camera, and I can see that kind of stuff happening. But the main thing to know is that this is the kind of effect that I'm going after to mimic some of the effects of a triode. And there is a lot of math and a lot more equations and graphs and all that kind of stuff, which I will get into next time. So if you're interested in that kind of thing, do consider subscribing. Love to see you there. And I will check you next time.